Okay. Here's question 9 of 2008 paper. I'll only be talking about questions that are relevant. So this is resistance temperature characteristics of a thermistor shown in figure 7. What is the value of the resistance of the thermistor at 20 degrees Celsius? Easy. 20 degrees, 1000 ohms. Easy mark. Now we stick it into this diagram. Not so easy. Circuit is shown below. So this is our thermostat. This is where we change temperature and it's going to change the resistance somehow. I don't know how. And then we have a variable resistor. So I want the refrigeration unit to switch on when the variable resistor here is 4 volts. And switches off when it's less than 4 volts. We want it to turn on at 5 degrees. That's important. At what value should the resistor be set so that the refrigeration turns on at this temperature? You might show you're working. So we know this is 5 degrees. So I'm just going to go 5 degrees implies thermistor has a resistance of resistance of 5 degrees, 4,000 ohms. Okay, so now our circuit looks like this. Therefore, drop across 4,000 ohms equals 8 volts. Well, we could even use the divider formula here, but I like thinking of it like this. If this is 8 volts, this is 4,000 ohms, and we know the voltage drop is proportional to the ohms, the resistance, if they have the same current. Because look, voltage equals IR. Yeah, and they have the same current. So if this is proportional to that, I know this is just half. The voltage drop will be half of that. So the resistance will be half of that. Okay, you can say all the things. Another way you could do it, you could find out the current going through here, I, and then say I times R equals 4, and then you could do V divided by R, and you'd get that. Or you can just try and explain this. Okay, so I'll show you which formulas to use. I equals V on R. 8 volts divided by 4,000. And then we go I times R, this one that we want, equals voltage. Or the current from that, I times R equals 4 volts. Yeah. I'll change this I for you. It would become 8 over 4,000. So that kind of solves everything. But that's just a few different ways to do it. Okay. 2,000 ohms. The cool room is not cold enough. To set the temperature lower, should R be increased or decreased? Explain your answer. Okay, if we want to set the temperature lower, we should see what setting the temperature lower actually means. So if temp is lower, then if we move the temperature lower, the resistance goes up. Then implies thermistor goes up, and that implies to keep the same ratio. So if this goes up, and we still want this to be a ratio of 8 to 4, then this must also go up. Between resistors implies variable resistor has to increase. Yeah, that's roughly it. And that's it. Electronics. Cheers.